Hello, this is Mrs. Sargent, and this is lesson 4.7, Molecular Shapes. So far we've been drawing our Lewis structures just on a piece of paper. We can't see what they look like in 3 dimensions. Our molecular shapes are going to show us our molecules in 3 dimensions. What happens with the bonds, the angles, and our lone pairs. So just as a reminder, a lone pair is unbonded electrons. So we've been representing these by dots, and we always have those dots in a pair. So that's why it's called lone pair. We're going to be referring to this quite a bit today, especially when it becomes the lone pairs on the center atom. What does VSPR stand for? It stands for valence shell electron pair repulsion. So valence electrons are what we use to draw our Lewis structure. The shell is another name for the energy level. And then electron pair, our electrons are always found in pairs. And repulsion. When I think about repulsion, I think about when you've left some trash in the trash can and you leave for the weekend and you come back and it smells really bad. You're repulsed by that smell. You want to get as far away from it as possible. So our bonds are going to be repulsed by our lone pairs and by other bonds. And so they're going to move as far away as possible from those other electrons. So we have this model to help us with our molecular shapes. So if I start with 2 atoms, my total number of atoms is 2. Electron pairs around the center atom. We don't have a center atom because we only have 2, so go ahead and place an X in that box. We don't have any lone pairs on our center atom, so you can place an X in that box as well. The bonding areas, we have 1 bonding area. I think your packet says bonding pairs. I would change that to bonding areas. That just makes a little bit more sense to me. So to sketch the molecule, I draw a circle and a line and another circle. The bond angle, you can put an X in the bond angle box as well. We don't have another bond to measure the angle between them, so you don't need to worry about that. The shape here is linear. Our atoms are in a straight line, so they are linear. So then if I add a 3rd atom to this, so now I have a total of 3 atoms, electron pairs around the center atom. Each bond has an electron pair. So I have 2 bonding areas. I don't have any lone pairs on my center atom, so that is also going to tell me that I have 2 electron pairs around the center atom. The molecular shape for this is linear. The bond angle is 180 degrees. Straight line is 180 degrees. Notice that this molecular shape is linear, as well as our model with just 2 atoms. So there's 2 different types of linear molecules. So then, if we add a lone pair onto our molecule, everyone thinks that this looks a little weird, but remember Shady Schrodinger, he said we don't know exactly where those electrons are at any one time. So what this is showing us is that they're somewhere in this electron cloud. We've represented them with the yellow dots, but they could be really anywhere within this cloud. So we still have a total of 3 atoms. Electron pairs. Let's first count our bonding areas. We have 2 bonding areas. We have 1 lone pair. Each of these represents your electron pair. So we have a total of 3 electron pairs around the center atom. The bond angle is 120 degrees, and the molecular shape is bent. It's no longer in a straight line, it has bent, so that is the name of the shape. So I would draw this a circle, two angled lines, another circle at the end of each of those, and then the lone pair. I wouldn't worry about drawing the electron cloud, just the lone pair. So, let's see here. If I remove, or if I add another lone pair, changes the shape a little bit. Okay. So I still have 3 atoms. I still have 2 bonding areas, but now I have 2 lone pairs, so that gives me a total of 4 electron pairs around the center atom. And my shape is still bent. However, my bond angle is now 109.5 degrees. So to draw this, draw a circle, 2 angled lines, lone pair there, and a lone pair there. That's how I would sketch this molecule. And then if I remove these lone pairs, remove those lone pairs, and then I add in a 4th atom, I want you to see how it's all like in the same plane. It's all, it's like on a plate basically. So the number of atoms we have total is 4. We have 3 bonding areas. We don't have any lone pairs. So that's going to give us 3 electron pairs around the center atom. The bond angle went back to 120 degrees. And the shape of this is trigonal planar. So that planar shape plays into the name of this. So now, if I keep the same number of atoms and I add a lone pair, do you think it's going to change the shape of the atom or not? Or the molecule or not? Well, let's see. Add on the lone pair, and sure enough, it did change the shape. It's no longer in the same plane. Okay. So now I still have 4 atoms. I have 3 bonds, 1 lone pair, so that gives me a total of 4 electron pairs around the center atom. My bond angle is 109.5 degrees. The molecular shape is trigonal pyramidal. And to draw this, I would draw my center atom, circle, circle, angles away. This one I'm going to draw a little bit shorter to show it's going in another direction, and then I'm going to put my lone pair on top. So now, if I remove that lone pair, and I replace it, so it goes back to that planar shape, but I replace that lone pair with another atom. I've now changed my number of total atoms. I have 4. I have 5 total atoms. I have 4 bonding areas, 0 lone pairs, and I have 4 electron pairs around the center atom. The bond angle is 109.5 degrees. And the molecular shape of this is tetrahedral. Think about this. We have 4 atoms coming off of the center atom. The prefix for 4 is tetra. So it is tetrahedral. So it's going to be similar to the last one, but instead of that lone pair on the top, you're going to draw another atom. Okay, so now if I add in a 6th atom, changes the shape a little bit more. So I now have 6 atoms total. 1, 2, 3, 4, 5 bonding areas, 0 lone pairs, and I have 5 bonding areas around the center atom. The molecular shape is going to be trigonal bipyramidal. So to draw this, center atom here, go there, like that, one coming up top, and then one going back that direction. That's how I would draw this molecule. And then if I add in a 6th atom coming off the center atom, so now I have a total of 7 atoms. I have 1, 2, 3, 4, 5, 6 bonding areas, 0 lone pairs, so that gives me a total of 6 electron pairs around the center atom. The molecular shape is going to be octahedral, and the bond angle is 90 degrees. I think this kind of looks like a Jax from your Cracker Jacks box. And I would draw it something like that. If you notice on the back of your periodic table on the right-hand side, you have a chart that is similar to what you just filled out in your notes. You are going to use this to determine the molecular shape after you draw your Lewis structures on page 18. So remember, your Lewis structures are very important to draw them accurately. I'm not going to ask you to draw this molecular shape, but I'm going to ask you, based off of your Lewis structure, what is that molecular shape? So if you can draw your Lewis structures correctly, you should be able to correctly identify the molecular shape. Molecular shape is going to play into polarity that we're going to talk about to finish up our unit before our test. So make sure you work through the practice on page 18. Remember, when it's referring to lone pairs, it's referring to the lone pairs only on the center atom. So make sure you keep that in mind as you work through this. Stop by and ask me any questions if you need help. And thanks for stopping by. Have a great day. Bye.